In this video, we'll take up the Chapter 6 review homework. So the first question is asking what's the pattern and write the next three terms. So I would argue this question, even though it's pretty straightforward, it's the basis of the unit. It's all about pattern recognition. So like for the first one, 1a, you're just dividing by 2. For 1c, you are increasing the magnitude by 5 and then but alternating the signs. Yeah, so not much to say. Using the pattern that you develop, you can state the next three terms. But number 2, another great question because it's about pattern recognition. But hopefully these questions are easier now because you have you've enhanced your skill set. You can generate the explicit formula for an arithmetic sequence, for a geometric sequence. So when you first did these questions in the beginning of the unit, they were much more challenging. But now, like I said, you've enhanced your skill set. So hopefully you find them easier. You were able to find the explicit formula pretty quickly. And once you have the explicit formula, you can find the 10th term of the sequence. And I should really say n is a natural number for all of these. It's very easy to forget, but definitely don't. Remember, the focus of this unit is on discrete functions. And we're focusing on discrete functions with the use of sequences. All right, for the third question, write the first 4 terms of each recursion formula, So for 3a, I actually just took a shortcut. I saw the pattern. I just wrote down the first 4 terms. Now for 3b, c, and d, I just showed my work. It's a little tedious, but like for example, to find the 4th term, you need a 3rd term. But to find the 3rd term, you need the 2nd term. And to find the 2nd term, you need the 1st term. So it's the drawback of the recursive sequence. So one of the ideas that we talked about in the lesson, the unit, is that if you're able to choose between a recursive formula and an explicit formula, we would choose the explicit formula. All right, so that's 3. Number 4, the number of terms. So once you use the general term formula, you can solve for the number of terms in that sequence. Nothing special there. Okay, for question 5, it's basically an arithmetic sequence because the salary is raised by 1,600 every year. So yeah, it's just an arithmetic sequence. All right, let's do question 6. So it's asking us, are the following sequences geometric? Well, in order to be geometric, you need a common ratio. So if the answer is no, then it's not geometric. And if there is a common ratio, whatever it is, then your sequence is geometric. For question 7, given 2 terms, they want me to find a and r. So I showed my math. Now r could be +2 or -2. For b, they're saying why are there 2 possible values? Because the even terms, your odd terms have to be strictly positive, but your even terms, nothing is forcing your even terms to be positive. So they could be negative, which means you have 2 possible values for r. And then writing first 5 terms, that's fine. Question 8, it's just a regular geometric sequence question. Not much to say there. You could use logarithms if you want for 8b. All right, question 9, we have an arithmetic sequence. Yeah, not much to say. Once you establish an arithmetic sequence, then you can answer the questions. Now for 9b, they changed it to an arithmetic series question, but nonetheless, use the ideas from the arithmetic sequence, and that will help you find the sum of the first however many terms. For question 10, it's another arithmetic series. Yep, it's an arithmetic series because the earnings are growing by 10, and you want to find the earnings over 10 weeks. So you're basically finding the sum of the first 10 terms of this series. All right. So for 11, they want me to find the sum of the first 9 terms of the or they're telling me that the sum of the first 9 terms is 144, and the sum of the first 14 terms is 329. So using that information, you can build a linear system. For question 12, it's now a geometric series. And 12b is a nice application of your knowledge of a geometric series. If you want to know that like the 6th to the 11th term, you have to take the difference of the S sub 11 and S sub 5. Okay, for question 13, we have another geometric series. Yeah, not much to say there. 12 terms because there are 12 months. And lastly, we have question 14. Sum of the first 2 terms of a geometric series is 4, and sum of the first 4 terms is 40. So if the first 2 terms is 4, then A plus AR is equal to 4. Because there's first term, second term. If the sum of the first 4 terms is 40, then you can use the geometric series formula, or you can just say A plus AR plus AR plus AR squared plus AR cubed. But I used the geometric series formula. Now here, you could factor this because there's a difference of squares here. But the way I chose to do it, I just follow very closely with your algebra. I perform the substitution because A is equal to 4 over R plus 1. So if you perform the substitution and then you simplify this a little. So I'll show an extra step here. You can multiply both sides by R minus 1 and you'll get this. You get 40 times R minus 1 equals 4 over R plus 1 times R to the power 4 minus 1. Okay? And then I multiply both sides by R plus 1. Okay, and then I'm able to get what I have over here. Because this is a difference of squares, so that's why it's R squared minus 1. And R to the power 4 minus 1 is, once again, a difference of squares. So you can divide both sides by R squared minus 1. Be careful if you do that. You should really state the restriction. Because now you're saying R can't be plus or minus 1. Right? Because if it was plus 1 or minus 1, then you're dividing by 0. And we can't have that. So we divide both sides by R squared minus 1, so you're left with a quadratic equation. Solve for R, plus minus 3. Beautiful. No problem with plus minus 3. If you solve for R and you got plus 1 or minus 1, you'd have to reject it. Anyways, it's not plus or minus 1, it's plus or minus 3, so it's beautiful. You can solve for the 2 values of A. If R equals 3, so if R equals 3, okay, then A is equal to 1, using what we know about A. A is equal to 4 over R plus 1. Now, if R is equal to negative 3, there's a different value of A. If R is negative 3, then A is negative 2. Bam, bam, bam. There are, that's your first 5 terms of the geometric series. And of course, there are two possibilities because you have different A values and different R values. Okay, but I would definitely check. Are the first 2 terms give us a sum of 4? Yes, 1 plus 3 is 4. Negative 2 plus 6 is 4. What about the sum of the first 4 terms of the series? 1 plus 3 plus 9 plus 27? Beautiful, that's 40. Negative 2 plus 6 plus negative 18 plus 54? Beautiful, that's 40 as well. Okay, so that's the review sheet on chapter 6.